Okay, was it starting? Yeah, so like I think like few concepts were left from the feature engineering. Let's cover them. Like then let's see like some theoretical concepts behind LLMs and some API integration and all the backend stuff, right? So that you get the clear understanding when we do it practically. So
Yeah,
last time like we saw like how the we created the dummy data and like then handling missing values and creating a new feature, like how new feature can be created from our old features of old columns, the useful new columns, basically. Then we saw that how the label encoding is performed, right? How the label encoding and one-hot encoding is performed and implemented,
yeah,
right? But now
yeah.
now let's see like what the one-hot encoding. So yeah, I think I didn't show you the result, resulting data frame. Let's see that like how it looks. So I have applied a label encoding, right? The label encoding is this one. So basically it will take your all the categories and it will convert them into numbers and that in a one column. Let's see like how
Okay,
it looks. So if you see that the gender encoded, this gender earlier which was in a textual data, now it is in a numerical data and how this is how it looks.
okay, okay. Cool, cool, cool.
So there can be one thing that potential one problem that I was trying to tell you in the last session, like when it ended, like that if you have multiple categories here, right? Suppose say it is colors, like red, green, blue, pink,
Yeah,
orange, purple, right? Now, if you understand that in the textual data, they don't have any quantitative measure. Like red is not greater than orange, or pink is not smaller than purple. Right.
yeah.
Those are colors and those can't be measured. But when you convert them into numbers, actually what happens is they are getting ranked.
Okay.
Right. Here if you will see, if you are converting this island, I don't know what it is, Iceland or island, or like whatever it is, if you will
Yeah.
see that it is basically ranking them, right? Like Tor Gerson is like 0 and Dream is like 2. It is ranking them, but we don't know like whether it is good to rank them or not. Like they may be like a flat, a plane, in a plane dimension, like they can be equal. Like it is
Yeah.
not a good thing to rank them, right?
Yeah.
That can be a very serious problem there. So we have a solution for that, that can be our one hot encoding, where we just keep all the columns and 0 and all the column that are not there as 0, and which column the category that is there in the record, that will be 1. So to apply it, there is a function. So now you don't need to use sklearn. There is a function in pandas itself. So for a label encoder we used sklearn, and in that label encoder there was a function that was a fit transform. So we are transforming, right? So that's why it's named as fit transform. But for one hot encoding, you don't have to use sklearn. You have it in inbuilt in pandas. In pandas, you have the function named as get dummies. Hope you get it.
Yeah.
So this get dummies will convert each category into a separate binary column, like 0 or 1, right?
Yeah. Yeah.
Each each category into a separate binary, like 0 or 1. So here we want two columns. This is a column city and this is a column gender. So for these were categorical variable. Now we want to convert them into numerical variables. Like this, Delhi is repeating. So this can be 1 1 for this column and 0 for Mumbai, Bangalore, right? So let's see like how it works. Hope you got this, right? How it works. we have defined it. This screen is visible or notes? Are notes visible? Hello?
Yeah, I can hear you.
Yes. So, yeah, the notes screen is visible, right?
Yeah, it's visible. Yeah, it's visible. Yeah,
Yeah.
yeah, yeah.
So here also, like you can see that, like in the last session, we saw that for the column that the value is, it will be one and the other will be zero, right?
Yeah. So anyone that is active will be one, every other one will
Mm.
be zero.
The inactive will be zero, the active one will be the one. And so it is straightforward to apply it. But now see, this is a very straightforward data. That's why it is like in one sentence only. But if you are working with a big data, like if you are working in a real time or the data that is generated in a real time, then this function will be a little bit complex. Here will be a very huge code that will is written, and here this code will be continued. Here this code will be responsible for getting this data frame, right? And the output of this data frame will be used in the later part. So whatever you are seeing here is just a subsection. Don't think that this code will be this easy to understand in the real problem, but it will be very easy if you break this down into such nuclear components, right? So like here this code was very big, but I have broken down it into some smaller parts, right?
Yeah.
So now this is very easy to understand. So the
Okay.
same thing you have to do, like whenever you get a problem or whenever you are dealing with any big data, like you have to cut down the data, you have cut down the problem statement into a very small pieces so that it will be understandable, right? So this is a trick that you can use to solve your problems.
Okay.
Okay.
Yeah.
Now here, like we want to see like what the output is. Now let's see what the output is. Like we had this data frame which had these many columns, age, gender, and all this. Now let's see, after performing the get dummies one-hot encoding, the one-hot encoding should create all these columns, right? This will be very interesting to see. Let's see are in columns. It says are in none of the objects are in column. Gender and um, um
I think
should
you might need to gender and city in double brackets. Gender and city, yeah, double brackets. One
I
more.
think this
Yeah, yeah, yeah. Put them in. Yeah, exactly.
no index. We can try doing chat GPT it, or also we
Okay.
can use explain error here, so it should answer. So basically this is a syntax error, I guess. So we need to pass the gender and city columns inside the get dummy variables. Um, df column, so this is the same, I guess. The first is the same thing, right?
Yeah, it seems so.
Hmm.
Maybe the df is supposed to be df.show or df.ed.
Mm,
You could do df.ed.
no, here we are using df only.
That
Are
df,
you saying
no,
this?
no, no, down, no, the second one. No, no, dot,
I'll
dot,
change the name.
no.
Hmm.
Take out the one. You delete the other one. Go down, go down, go down. Dot, df.ed, df.ed.
No, no, no.
In
Like
brackets.
df. Hmm. Yeah, df dot head will basically just give you the five values, top five values. But all
Yeah,
if you write the df also, like it does the same thing. So it does end and it will not give you any other solution. But
Maybe you might need to use ChatGPT. ChatGPT debugs faster.
hmm, what? Let's try it. Or I have the Perplexity Pro, so we may try that as well. Do you use Perplexity sometime?
ChatGPT. I use it most of the time. I use it every time. It gives me my code, but I already know what I want to do. Just praise the syntax.
Gender is also okay. Gender is not there. I see. I see. But why gender is not there? Okay. Okay. Okay.
I think you need to
Okay.
run
You
column
see
here.
here. You see here. Like here, what we did is like here we fit transform data df.gender. So basically, it completely transformed it. Right. So this basically deleted this gender column. Now we don't have the gender column here. Earlier we
Okay.
had. Now we don't have that gender column. Now
Okay.
there is a gender male, this column,
Okay.
right? City column. Okay, let's do one thing. Let's run this new cell where we just have this gender and city. And
Yeah.
now run this. So here we will see this our data frame. This is the data frame, right? After one hot encoding, after completely converting this gender and city into the dummy variables, we have this gender male. So here also it will be convert this gender. Now it don't have the gender, right?
Yeah.
So it have converted that gender into
And task convert
gender male.
city.
Hmm. Yeah, gender male. So now see one more beautiful thing here. What is done here? If you see, can you see something here? Like what we discussed, here is a little bit difference here. The idea
Yeah,
is
I think
same.
it has turned the categories to columns.
Categories to columns. Yeah, it is converted.
Transpose.
The categories are converted into column. But
Transpose. Yeah.
hmm, hmm. But one more interesting thing, we saw that here that these columns are converted into all those like here the three category and three columns. But can you can you can you can you see this that convert for if you have three categories, just two column will be sufficient. Can you tell me how?
Because you just use yes and no or something like that. I don't know.
Uh,
Oh, you
this
decode and
mm, no. See, you have a color, suppose color red, blue,
yeah.
and pink, right? These are three colors. Now to define it, how many column do you think you can define it? The least number of column,
Hmm.
huh?
How many columns do you think I can define?
Like if you want to convert it into numbers, numerical
Oh,
form,
oh, that would be 0, 1, 2. No, 0, 1. 0, 1, 2. Yeah.
0, 1, 2. You're saying that three column. One is for
Yeah.
red, one is for blue, one
Yeah.
is for pink, right?
Yeah. Yeah.
So if it is red, then it will be 1, 0, 0.
0. Yeah.
For blue, it will be 0,
0,
1,
1,
0.
0,
For pink, it will be 0, 0, 1.
1.
Okay. Tell me one thing. If I do it not three column, if I do it in two column, can I do that?
Yeah, I think so. It will be either 1 or 0.
Either one or zero. See, what I can do is I will just say red, pink. Okay. If it is
Mm-hmm.
red, I will not say pink. Okay. Sorry, I will
Mm-hmm.
not say blue, suppose. I'm not saying blue. If it is red, this will be one. That means one means true. Okay. So wherever
Mm-hmm.
I read the one, it is true. Zero, it is
False.
false.
Yeah.
So here it is red, so I'm writing it as one. And it is not pink, so it is zero.
Yeah.
Here it is blue. So what I will do? I will do is zero. It is not red, it is not pink. So zero.
Okay.
And it is pink. For pink, it will be zero, one. Now you see,
Okay.
we have represented all these three columns into just two columns. Must see three categories into two columns. So
That
we
will be
have,
yes, no, and others.
yes. So basically, this is a red yes, both no, and pink yes. So wherever there is both no, that means it is blue. We don't have to define it.
Okay.
It will be blue. So this is this kind of mindset you need to have while you are doing any data science project. Now see, we have saved our one column. We have saved this computation power with just this simple logic. Interesting, right? Here you are
Yeah.
just saying that red is there, so yes, red. Here it is no, zero. Both are zero. So that means that is there is a some third column that is active.
Yeah.
You don't have to define that. Because in numbers, we just have to explain that yes, this is a one category where this one and zero can be a combination. Zero and one can be a combination. So for this combination, it is red. For this combination, it is pink. And then we have a third combination that will be that can be anything. But since we have only these three categories, then this will be your blue. Does that make sense?
Yeah.
Yeah. So the same thing we have done here. The same thing this get dummies have done here. In gender, we had male and female. Two, right? Two thing. Here we had three. Now we have two. Now we have two. For three, we needed two column. So for two column, how many? So for two category, how many column do we need?
Um, 2 columns.
Yeah. If I want to display it here, for two column in this format, how many column do we need for two category?
2 columns.
Two columns. Can I do it in one column?
Oh, for 2 category, yeah, we can do it in one. Is 0.
Yeah.
If it's
Yeah.
not 0, then it is true. It is false. If it's
Yeah.
not false, then it's true.
Exactly. Exactly. So for one column that was the gender, then we have true. True means it is male, right? Gender male. So here we have defined that this column is for male. If we did it for gender female, then this will be false, this will be true, like the complete opposite.
Yeah.
For city, here were three category: Delhi, Mumbai, Bangalore. So for city here we have three category: Delhi, Mumbai, Bangalore. Now how many columns will be required?
2.
Two. Exactly. Two. City Delhi, city Mumbai. Now, how do we define Bangalore?
True or false?
What?
How do I do what?
Like, suppose I want to say that this column has Bangalore. How will I say that this column has Bangalore?
But that would be both false.
Exactly. Exactly. So, this has Bangalore. I will say that both are false. Neither Delhi nor Mumbai. Okay. Now, I think you got the concept well.
Okay.
So, this is the main idea that a data scientist should have, that how he
And
have
this is
to.
called one-hot encoding. Yeah.
Yes, one out encoding. The technique is, the purpose is same, to convert numerical into categorical, but the technique is different. Label encoding or one out encoding. Okay. In the notes I have mentioned above on our earlier classes, here one out encoding, and I can mention it here, label encoding. This should be a label encoding. Just a minute, huh? Yeah, this is one out encoding only, and this is label encoding. If you need the clear notes, I will try to send you them. Like, I think since it is a live class, so I'm not able to properly write them.
Yeah, that's fine. That's fine. Yeah, you can send me the notes later, but I'm just jotting some keywords down. That's fine.
Yeah, that's great.
But,
That's great.
but I
Very
will
good.
appreciate the notes and the video and the recording later
Yeah,
on.
sure, sure. Will it be fine like if I post this video on YouTube? I send you the
Yeah,
link.
that's fine. As long as my personal informations are not there and all of those, but that's
Definitely.
fine.
I think your name can be displayed.
My name.
I think this will be beneficial for you, like to have a proof that you have taken some a course to learn and you have spent the time to learn.
Yeah, kind of. That's fine, but we'll see. At least when I'm done with all of the course, then I'll decide. And at least let me get a job. I want to get as soon as I get a job. Don't worry, anything you want, I'll do it for you.
Okay, okay, okay. Okay, so I will share
Just
you the drive link only. Let's see like how it goes.
yeah, you can see that I'm getting the
Okay.
concept. It's just
Hmm,
you know
hmm, hmm,
having hands-on where I can do everything from the beginning to the end. So now I think what you've just taught me now is when I'm working, if the end goal is to build a data model,
hmm,
then all my features needs to be in numerical form. And
hmm,
after I've done all of the EDA and everything, the last part of the EDA will be like changing the categorical
hmm,
labels to numerics. And one of the way to do it is the one hot encoding, where I
hmm,
change all of the categories into columns
hmm,
that has either 0 or 1 or true or false, Boolean.
hmm.
Okay.
Yeah. Try to recall some more concept if you can.
Say that again.
Try to recall some more.
Sorry, I can't hear you. Hello? Hello?
Hello.
Yeah, I think I lost you a bit, but go on. Hello?
Hello.
Yeah, I think can you hear me?
Yes, I can hear you.
Oh yeah, I can hear you now. Go on.
Let me check. Yeah, the recording is continued. Okay, so yeah. So yeah, so we checked the one hot encoding. Now let's see what is your feature scaling. Right. Are you able to see these income and expense?
Yeah.
Hello. Now suppose just give me a 1 minute. Yeah, so one hot encoding, yeah. So one hot encoding is done. Now let's see what is the feature scaling. I think we also discussed it in notes somewhere around feature scaling. I told you the example of that, right?
Yeah,
Uh, 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 okay, cool.
I think feature scaling is choosing the features that meets our requirement or something like that.
Hmm. Yeah, that's feature selection. You have to
Feature,
you have to you have to have that clear picture of these concepts. That's feature selection. So I think we will see like what feature selection is. I can write. So basically, you can understand that some algorithms logistic regression, SVM, and neural networks, what they prefer is we don't have to have some huge values like values like 2000 or 20,000 or like any number like 8979988, right? A 00. But some values are there, like suppose say price can have this high value, right? But we don't
yeah,
have to want to have that. We want to have this value that will range from 0 to 1 or maybe minus 1 to 1. Okay. So basically this a function that will be applied to this value that will convert this value to a value that is between 0 and 1. Okay. The same so that they all can become in one scale. Right. Right. So basically, the concept is to make sure that some algorithms like logistic regression, SVM, neural networks, they get to the convergence. What's the convergence? Convergence is here. I showed you that, I think, and that gradient. So you'll get that, yeah, here. So we have to converge that, right, to a point where it is the best, right? Do you remember this? There's a point, there's a
yeah.
value at this point. We need to bring it at to the bottom where it is the best fit line. Or sorry, we can say uh the best value for this variable, right? So some algorithms expect it to be in a scale from 0 to 1. So we
Yeah.
need to convert them it into that scale. So this technique is called feature scaling, where we convert any given feature into a value that is from between 0 to 1. So now here you are applying that feature scaling into your column that is your income and expense. And this function come inside your sklearn library. Inside a sklearn library, there is a class that is your standard scaler. This is your sklearn library. Inside your sklearn library, where your pre-processing, right? All of this thing that we are doing is called pre-processing. Okay.
Okay.
So inside
Okay.
this pre-processing, we have a label encoder, standard scaler, polynomial feature. So label encoder we used earlier. Now we are using standard scaler. So in standard scaler, basically this will scale these values from any range, any number ranging from suppose 50,000 to 70,000 or say 20,000 to a range that will be from your 0 to 1, right? And for this, we will be using
Okay.
fit transform.
Okay.
Okay. This this is giving yeah. So expense income. Now we will transform this value. You can see how this looks. DF. So it will print me the income
Okay.
expense. So it has scaled this value, not here like exactly from 0 to 1, but it has reduced this value. Like it may be like from -1 to 1, or maybe some value like
And
in a
if we
smaller
want to
scale.
do the relationship between both of them, then we can just use correlation matrix and
Hmm.
MATLAB and Seaborn to view the relationship between income and expenses.
Hmm.
Is it possible to do that, or
Yes.
is not?
Yes, it's possible to do that, but it is not necessary to
Yeah.
see whether there is relation or not.
Okay.
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 But this is necessary to do the feature scaling here
Yeah. Yeah.
to make sure that it works well on those algorithms. Let me write the algorithm's name here that for which this is important, like for your logistic regression. So we discussed, I think, regression and classification. The difference between regression and classification, if you can tell me, will be better.
Classification is learning on labels, assigning labels to features, training the computer to learn, training the model to learn on the input and output. However,
Mhm.
regression is
Mm, mm,
only
mm, mm, mm.
no, only no inputs. It just needs to learn on its own and output something. No inputs without output.
That is your supervised and unsupervised.
Oh, sorry.
Continuous variable. Okay, so regression is your basic continuous variable. Like example, price. Like it can range anything. It can range differently, right? Like 2377 dollars. Right? It can be anything. Like if I place two with one, so it has very diverse value. Another is your classification. So the example that you gave me for classification was the dog and cat, right?
Yeah.
So that is a classification example. Like it will be a discrete variable.
RET. It's yeah. Yeah.
Yeah. Okay. So this is important for this standardized regression. Standard scalars is important for logistic regression, support vector machines, and neural networks. We may talk about this neural networks and all these things later. Okay.
Yeah.
Hope you understood this topic.
Say that again.
Hope you understood this topic.
Yeah, yeah, yeah. I feel like I'm understanding it.
Uh-huh.
It's just it's just to be able to know everything, and when I have a task and I know, okay, I need to do feature scaling, I need to do feature engineering, I need to
Hmm.
do this, I need to do that, and I understand. But I
Hmm.
know I will wait because most of all these things I already know it in. I know something similar in data analysis. I do a data analysis, I work with data engineering, building pipelines, so I already understand some of them. But this is a different, a
Hmm.
different world in on its own, and it's nice. I'm enjoying it.
Like this is the core thing that a data scientist do.
Yeah,
Just so you need to understand these concepts, like how to tackle
yeah,
them.
yeah, yeah.
So suppose
The
say like,
algorithm.
yeah, please say. Are you saying something?
Yeah, yeah, yeah,
Okay. So like now, like suppose that there is a different challenge that we want to solve now. What is that is there is a continuous variable here, right? That I told you.
yeah,
Continuous variable means it can range anything from 0 to suppose. Like there is no limit like it. There's like 0 to 100, it can be anything. Like even between like 1 to 10, it can be anything. Like it can be 9, it can be 9.1, and it can be 9.1222. So it is a continuous variable, right? Now suppose say I want to convert this continuous variable into a discrete variable, right? Discrete variables means like there can be some specific number, right? Discrete means like 5 or 4. There can be 5 uh, classification, for classification, for category, like that. So suppose you want to convert this continuous variables into discrete variables. You understood the difference between continuous and discrete?
Yeah.
Okay. So continuous variable examples, can you try to give me?
Continuous is like regression 1 to 1,700,000
Hmm, 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 hmm.
numbers.
So let's take 72200 and
Yeah,
take 32000, say
yeah,
48000. Okay.
yeah,
Now how I will convert and also let's take 21566. Now how and suppose there are more like below this. Now how will I convert this into a discrete so that there is only three identification. Like here are like many variable and all are different, right? I want they should be only in the three data point. I can identify. I should be able to identify them on the only the three of them.
yeah.
We
We
are,
do feature scaling, giving it
mm,
this one to this one is zero, down to another one is one, and if
mm, mm.
it's not to zero, is yes or no, or both are no for the third one, sort of thing.
And no, actually we can't do that because like suppose this may be a price, and if we will do any changes on this price can change. Okay. So
Yeah,
what we will try to do is we will try to simply create some bins. What we will do
yeah,
is we will try to create some bins. Suppose if this value was anything from 0 to 1 million, 1 million, anything like 0 point anything, suppose all those values, right? From 1, 2, 3, 4, 5, 6, all the values came from 0 to 1 million. But suppose I want to convert it into a discrete, so I will do it. I will cut this in three parts.
yeah,
So now I have three bin. One bin, two bin, three bin. One bin lies from 0 to 200K. Third is from 200K to 600K. Second is 200K to 600K. Third is from 600K to 1 million. Now there is only three bins. Now this is discrete, right?
yeah,
6K to 1 million, 2K to